Hello and welcome, my dear grade 8 elite students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming all of you to today's session on lesson 6.5, graphing inequalities in two variables. I'm going to be covering in today's session how you can graph the solutions of linear inequalities in two variables. So let's get started. The vocabulary words for today's session are going to be boundary, half plane, closed half plane, and open half plane. We are going to understand the meaning of these words in today's section. So as you see, the graph of a linear inequality represents the set of all points that are solutions of the inequality. So you know already how to draw the graph of a linear equation. So today you are going to use that knowledge of linear equation to draw the graph of linear inequality. Remember, the graph of a linear inequality represents a shaded region or a shaded part. So it is going to be having an edge of the graph which is called the boundary. So the straight line is going to be having giving it a boundary. Now this boundary can be of two types. It can be a closed line or a closed boundary, or it can be an open line or a dashed line, which is going to give you the open boundary. Accordingly, there will be two half planes, closed half plane and open half plane. So the boundary divides the coordinate plane into regions called as half plane. So two parts it will be, one can be smaller, one can be bigger. They're not exactly half actually, but yes, they are called half planes. And when the boundary is included, the solution of the linear inequality is called a closed half plane. So for example, this is your y-axis. A quick short diagram I'm going to draw. This is an x-axis. For example, I draw the graph of a line. This is the line. Then this is a solid line. It is dividing into two parts. First, this part left and right. So these two parts are called half planes. Now, when it is a closed half plane, it is a closed boundary, closed line. If it is an open half plane, it will be dashed line. So accordingly, there are two boundaries. Okay, now when the boundary is included, the graph is a closed half plane. Like for example, if I want to just use a different color here and show you this region number 2, this is a closed half plane because this line is closed. If this line would have been broken like a dashed line, like this, if I just draw it one more time like this, then it would have been an open half plane. So this is a dashed line which the boundary is not included, therefore it is an open half plane. I hope the difference is clear to you. And for solving the questions today, we are going to follow three steps: step 1, step 2, step 3. In step 1, you will graph the line, the linear equation, and then the boundary, which is the line. Now you will use a solid boundary when the inequality contains less than equal to, greater than equal to. So if equal to is included, the line will be solid. If the equal to is not included, like this, then it will be a broken line or a dashed boundary. Then you use a test point. Generally you use test point 0, 0 to determine which half plane should be shaded. If 0, 0 putting this gives the inequality true, then shade that region which contains 0, 0. If it does not hold true, if it is false, then shade the other region. Then shade the half plane that contains the solution and that shaded region. So the solution, the graph would be this shaded region, as you can see what I have drawn here. That would give you the graph of linear inequality. Okay, so enough of talking. Now I will go to a question. Let me show you an example and let's solve it together. So a quick review of the question. In step 1, we convert to slope-intercept form. So y equal to mx plus b. You get your slope m as 3 by 2. You get your b as -4. So step 1, where you graph the boundary, you graph the line, you convert to y equal to mx plus b. This is what we had already discussed. In step 2, you use the test point, which is 0, 0. This comes out to be true. That means 0 is going to lie. Now, for drawing the graph, your slope was 3 by 2, which was rise over run. And your intercept was -4. So on the y-axis, 1, 2, 3, 4, -4. Then rise by 3 here, run by 2 here. This is the next point. So therefore you get the graph. Now it was a strict inequality, 3x minus 2y less than 8, strictly less. So if it is strictly less, then it is going to have dashed line or broken line. That's why you have this broken line that you see that you have drawn. Now 0, 0 was lying here, the test point. It satisfies, so this whole region which is shaded is going to be a solution. So because the test point is a solution of the inequality, you shade the half plane containing the test point. So this is how you draw the graph. The graph, remember, is a shaded region. It's not a line, it's this whole region of points. So any point that lies in this region, in this shaded area, would be a solution of the inequality. But if it lies on the boundary, it will not be a solution. If it lies outside, it will not be a solution. So for example, you are given an inequality 3x minus 2y less than 8, and we need to draw its graph. Then how we are going to do? Let's do step by step. So first we will do step 1. Step 1 tells you graph the boundary. So you are going to take this inequality just like a straight line, because the boundary is going to be a line. So it will be 3x minus 2y equal to 8. So you take it like a line, you will draw the graph of the line and then use it. Now we will write this in slope-intercept form, because to draw the graph, it is easy to draw it in y equal to mx plus p. I hope you remember. This is slope-intercept form. M is the slope, b is the y-intercept. So let's convert this equation. So minus 2y will be here. This will move on the other side because x and the number has to be together. Y has to be alone. So I keep this minus 2y here and move 3x here. So minus 3x plus 8. Now I need the coefficient to be 1. So I'm going to divide by minus 2 on both sides. So when I divide by minus 2 on both sides, what happens? Let's see. First of all, the sign changes. Minus minus becomes plus. This gets cancelled. Minus minus becomes plus. And this also gets cancelled. So y equal to 3x by 2 minus 4. Now, is this in slope-intercept form? Let's compare. Y equal to mx plus p. Yes, it is in slope-intercept form. So what is the slope? 3 by 2. What is the y-intercept? Minus 4. That means the graph will meet y-axis at what point? Minus 4. Okay, and slope, I hope you remember, by definition is rise over run. So that means we are going to rise by 3 units and run by 2 units. So now let's do the graph of this. So I'm going to draw a rough y-axis and a rough x-axis. Now here I have very less space, so let me go to the next slide. And before we go to the next slide and do the graph, let me also give you a little bit hint about step 2. So now this was the line we need to draw for the inequality. So we need a test point. So generally the test point that you take is 0, 0. So put this 0, 0 here and check. 3 times 0 minus 2 times 0 less than 8. Is 0 less than 8? Is it true or false? Yes, it is true. That means 0, 0 will lie in the shaded region. It will lie in the solution. So let's now graph it. Just quickly summarize. This is our coordinate plane, the x and y axis. To draw the graph, you convert this equation into slope-intercept form. Think of the equation inequality as an equation. Go and plot its graph. So for the graph, you use the solid line if it is equal to and dash line if it is not equal to. So -4 was the value of B. From there, you rise by 3 units and run by 2 units. So you get the next point, join the 2 points through the dashed line, you get the boundary. Once you get the boundary, take the test point, put 0, 0. If it is true, then shade that part of the region. So for us, it was true. So I'm going to shade this region which contains 0, 0. So this is our final answer. I hope you understood how you graph the inequality in today's session. Until then, this is Mr. Chika signing off from today's session. See you in my next video. Bye, students.